everybody. I'm Jonathan Dubner. I represent Vertica from HP, in from Toronto. Really happy to sponsor this event. I hear a lot of great things from David and Mina. Vertica is a small little company, part of HP. If you don't know about it, it was founded by Michael Stonebreaker, who was an inventor or behind Ingress, Postgres, and a lot of other companies. He's still fabulously successful in creating new companies and database products. And actually, if you don't know, he won the Turing Award a few months ago. I'm not going to talk to you about Vertica, as Mina is going to, from AdGear, is going to present it. We're really happy to have a happy customer. That's usually the best testimonial, as you guys know. But if you have any questions about it, we're an engineered-focused company. Not myself, but the people who stand behind me. So if you guys have any questions, interest, want to talk technically, we're more than happy to provide you information. So thank you guys for this opportunity.
Thanks for being here. My name is Mina. I work at a company here in Montreal called AdGear. And I'll take you through the story of how we ended up being happy customers of HP Vertica. We are in the ad serving business. So you guys are going to get like a double shot of internet advertising today. I don't think that was arranged. It just happened. So a little bit about myself. Like I said, I work at AdGear. I self-identify as a software hacker. I also like to play with networks and protocols quite a lot. And over the last 15, 20 years, I've started young. I've done everything from thinking of myself as a web designer to deciding to concentrate on the back end a bit. I really, really like SQL compared to some of the modern, less SQL-ish databases. Full stack, so one day I'm doing front-end JavaScript, another day I'm doing some kernel stuff, and a bunch of other acronyms that sometimes I don't even remember what they stand for. What I do at AdGear, at this point, I was employee number 1, and I helped build quite a few of the systems that I'm going to be talking about, including the mistakes that I'll share with you. But nowadays, basically, a whole bunch of smart people, I do my best to help them get work done and get out of their way. I still get access to the source code, so I can do things myself if I have to, but less and less. So if you haven't heard about AdGear, AdGear is a pure play internet advertising technology here in Montreal. And one of the main differentiators is that we are a full stack company. For our size, this is fairly rare. In terms of what we offer, we have a demand-side platform on RTB exchanges. We have a supply-side platform. And we started off doing classical first-party and third-party ad delivery. We also do, through our data stack, attribution, analytics, calculating, optimizing some of the things that you just heard about. Some numbers. We started off in 2008 as a very, very, very small company. Right now, we're approximately 40 employees. We are 2 offices. There is the office that I work in Montreal, and we have a fairly small Toronto office. Rough numbers. We serve 10 billion impressions per month, and more recently, as we started getting into the RTB business, we're doing 500 billion bid requests per month. To go over a little bit of terminology that you've heard about a little bit in the previous talk and in mine. In internet advertising, when a user sees an ad, that's called an impression. When a user clicks on an ad, it's called a click. Quite often, they click to go to somewhere where you desire some action from them. So if you actually measure, if you observe this action that you're looking forward to, this is called a conversion. All of these are just data events that occur. Our systems that we build are distributed around the world to serve these events as fast as possible. And our data layer that I'm going to be concentrating on, its responsibility is to count and analyze and reflect and report on these events. Sometimes as fast as possible. Other times we can tolerate a delay of a few minutes, an hour or 2, sometimes even a day. If you haven't heard of AdGear, I'm sure you've heard of some of the client-facing companies that are our clients. A lot of them are household name brands that you can recognize here. And we also power a lot of other companies that in the back end we are tightly integrated with, and we provide a full stack to that you might not have heard of. Sometimes they're agencies, they're advertisers, they're buying, they're buyers, or they themselves might be some sort of intermediary providing technology that we are the backbone to. All of the stuff that I've talked about, impressions, clicks, for rich ads, we measure interactions. So the user moused over an ad, they interacted with it a little bit. For videos, we say that they started watching the video, they've reached X, 25%, they've reached 50%. They hit pause, they increase the volume, they lower the volume. So all of these become data points into an event stream. And it is very important for us to accurately record and account on these events. In some cases, you might be able to observe an event and do an aggregation. It's slightly lossy. You don't need 100% accuracy. But in most of the case, the events that we observe, they are transactional. By that I mean someone somewhere is paying for it or being charged for it. It needs to properly enter the flow of data. So most of the volumes that I'm gonna expose you to, they're not lossy. And I can be honest. Basically, if our data pipeline has a stall, we get paged and we fix it. So we design as much as possible to be self-healing. If there's a problem, we try. But we design our systems from day one so that if we think there's something funny with the numbers, we do not give the user numbers that they can turn around and bill based on, and then it makes us look bad when we come back and correct it the next day. Like I said, the company was founded in 2008. By September 2008, we served our very first hit impression in the production stack. And I remember that day fondly because one of the company founders managed to put us on the homepage on simpatico.ca. This is high volume coming in on roughly week 1, week 2, so it really stressed our stack. I'm not going to talk about what happened that particular day, but we ended up scrambling to not bring our infrastructure down with the first high volume test. We thought we were doing pretty good at the time, and in retrospect, it's really funny to look at some of these numbers. Near the end of 2008, this is what the averages started to look like. So we averaged 2 events a second. 2010, we were up to 250 events per second. In 2014, we were doing almost 6,000 events per second. And this is geographically distributed, so we're pretty confident in our delivery systems at the time. Now, something funny happened in 2012. We said, well, okay, most of the traffic flowing through our system is what's considered classical transactions. A classical transaction is an agency calling a publisher and saying, hey, I like your website and I have someone who wants to put ads on your site. Let's make a deal, over the phone or over email. It's a classical buy, and it's an arrangement for the publisher to send you that much traffic for that much money in the next week, month, a couple of months. Or the other way around. The publisher calls agency and says, hey, I run a website, it's fairly successful. Would you want to put your ads on my site? There's a lot of manual back and forth gone in these classical buys. Now, it still happens, and this is where a lot of the premium inventory is bought and sold. But in 2012, we got into the RTB game, and this is another important acronym. RTB stands for real-time bidding, and it removes the need for this human transaction to happen. So as a publisher, I can say, well, okay, I run a website. I want to concentrate on producing good content on my site. So what I'm going to do is I'm going to connect my site to an exchange. And every time someone is looking at my site, when it's time to show an ad, it's just going to go to the exchange. The exchange in real time is going to find the best possible price from the best possible advertiser that this ad can be shown on my site. That microtransaction occurs, the ad is sent to the user. So when we got into the RTB technology, this is what the numbers really started to look like. 2012, we jumped to 80,000 events per second. 2014, we're doing roughly 200,000 events per second. So this gives you the notion of you can compare volume-wise. Now, they're not the same type of event. When we are observing RTB events, most of the time you're observing an opportunity to buy, or you're creating an opportunity to sell an impression. It's a little bit like the stock market. A whole bunch of computers are all connected to each other, and some computer is yelling, I have this and I'm willing to sell it, and a bunch of other computers saying, yeah, I want it, and a bunch of other computers saying, no, I don't want it. All of this has to happen really, really fast. We still need to receive this. So it takes, computation. There's computational costs. There's bandwidth, CPU, software development, all of that stuff. Databases that have to answer really, really quickly. All of this comes in memory, and in a few milliseconds, we have to decide, yes, I want to place a bid or not if we're buying, and if I'm going to place a bid for which ad, which one of my clients, and how much am I going to place? What is the amount that I'm bidding for? So this gives you an idea of volume. Now, from day one, when we were building the project, we said, this is what we want to offer our users. So when users log into our system and they're creating campaigns or inputting buy orders or sell orders or any of those transactions, this is what we want to offer them. From day one, we want to offer the customers a self-service reporting section in our user interface where they can get reports of what has happened. We want to make it responsive. We don't want the user to, schedule a report and come back after an hour. We want to make, we almost want to make it fun for the user to start playing around with the data that is the result of the orders that have executed in the system. We want to make it discoverable. So we want to, if the user, just wants to browse around and gain some insights, we want to be able to offer in the user interface some things that makes them say, well, okay, this is a little bit weird. Let me dig in some more. Give them the ability to dig in some more, to pivot around their data on almost any dimension that they want. We want to make them insightful and useful. And when we were starting, we were already competing against some pretty good big companies, but they have been in the game for a lot longer than we have. So one thing that we wanted to do is these companies were operating on the mentality that the day closes and then their batch system kicks in, and then by 8, 9 in the morning you get your data for the previous day. We said, well, okay, from day one we're not going to do this. Let's aim for real time and semi-real time if we can't go for real time. So even when we talk about batch mode, we're usually talking about 1 hour granularity. And since the reports is really the final thing that we're going to get to the customers, some customers are going to use it for insights. They're going to learn things. They're going to go back to the campaign configuration and say, well, okay, I don't want to spend money in this geographical area anymore, or I want to start targeting, I want to pay more money for users who belong to segment X or segment Y. So not only that, but a lot of our customers actually are going to take the numbers that we give them and bill based on them. So it's very important for us to have this notion of data completeness and safety, which is if we are not comfortable presenting numbers due to some issues we have on the back end, that it's much better to tell users the number that you've requested for the last 2-3 hours are currently not available, as opposed to give partial numbers that are flowing through a stream and we've computed half an hour or something like that. So that was by design from day number one. So we knew how to write the delivery software. And we figured the data, let's deal with it as we get it. We didn't have data before launch. So here's the plan. The software that we run on the delivery servers is just going to log locally what just happened. And we chose JSON logs. So every event that happens, there is a JSON record appended to a file that belongs to the current hour. And the event identifies basic things that you can think of. What is the current time, the IP address of the user that that just connected to us, what happened, what's the type of event. It's an impression, it's a click, it's a conversion, it's an interaction, all of these stuff. And each type of event has a family between 5 and 20 different attributes that further classify this event. For example, it's an impression. One attribute which is the actual ad, the creative ID that was shown. Which campaign ID it belongs to, which advertiser ID is, that campaign belongs to. And so we started accumulating this stuff, and we said, well, okay, let's worry about the data problem when we have a data problem. For now, let's just log, and we'll do our best to calculate. Besides, how hard could this step 3 be, right? You're gonna log events. We're gonna calculate. We're developers. We know how to run over a log file and calculate some numbers. So we thought. So this step number 3 turned out to be elusive, and I'm gonna walk you through 2008 up until now. So this is the initial data architecture, and I don't recommend you build anything like this. But nowadays, this is looking back. We had so for raw event management, like I said, each delivery server logs locally that this event happened. The logs are appended to a file that is named by the current UTC hour. UTC was chosen because you never have hours going back, you never have hours going forward. So all our data stack operates on UTC time. We wrote a library called Harvester, and we taught Harvester where the log files live on our servers, how many servers we are, where they are geographically, what their names are, and we gave Harvester SCP access so that it can wake up and go to the servers and say, I need this file now. Harvester lived on one machine, and it would wake up on the hour, and on a single file system, it would download the JSON that we've logged. And fairly early on, we realized that it is computationally expensive to go over JSON, especially if you're going to go over it multiple times. So this was before Hadoop was a thing. At the same time, Harvester would get the JSON files. We would create a mirror SQLite file. And the SQLite file had a couple of advantages over JSON. Number one, it gave us easy programmatic access with decent data types and predictable schemas for the data. And number two, it actually made the data a little bit smaller. JSON tends to be quite repetitive if you're doing an event stream because all of the keys are usually repeated. So with SQLite, you hoist the schema up to the top of the file, and then most of your file becomes data. When it's time to actually analyze this data, so 9 o'clock, we've harvested the logs and we brought them into this one big machine. We would have custom jobs that use the Harvester library. And the Harvester library, aside from knowing which log files make an hour complete, it also gave a streaming interface, an event-based interface. So you can write a job and you would ask it, give me all of the events for hour X, and Harvester would emit them to your job. And then in this job, we're developers, right? So we would write sum functions and average functions that operate on these streams, all of this, from scratch. And then finally, once that job has finished, you've got an in-memory representation of what happened in the hour. And all that job is trying to do is trying to collapse the volume of the data. We have, for example, a log file with 1 million events. If you essentially group by fields 1, 2, 3, 4, and then you get like a sum of how many of that compound key exists, you end up summarizing that log file into what we now know is called a fact table. It was a fact table in memory, but back then it wasn't a fact table. We still considered it a key value store. So the output from that job went into the PostgreSQL database. It wasn't even a separate database from our database. It was just a couple of reporting tables in the main application. So we would insert these key value stores, and then finally, when the user wants a report, well, we had it right in the same database the app is talking to. So we would fish out, we do point queries for the keys we need to compute the report that the user is asking for. Here's a start date, here's an end date, and I want group by X, Y, and Z. We only offer groups X, Y, and Z if we have pre-aggregated on X, Y, and Z. So we would fish out those keys, and then we will render the report to the user. This was in 2008. 2009, we made a small change. We discovered that SQLite files, the author doesn't publicly advertise it, but he offers a private extension that we bought. And over SQLite, you can actually do compression and encryption. We didn't care too much for the encryption, but the compression was really, really interesting. Because in a data warehouse, quite often, the bottleneck is your disk input and output. So if you actually manage to compress your data, keep the API exactly the same, suddenly our jobs ran faster. And this ran faster is going to become a recurring theme as we grow. So that was the main change in 2009.
Is it a report-based compression?
It's page-based.
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 So there's a little buffer.
Yeah, there is a bit of waste. But what was also interesting about SQLite is that for a lot of our reports, we had recurring needs to filter by one or two of those fields. So when we were creating the SQLite database, we can actually ask SQLite, hey, you're a database, create an index for me on field 1 and field 2. This made some of the queries that we would access the data with faster. Now, with compression, there was a bit of waste, but at least it knew, the index told it you need to seek to record 7 million. It knew that page, that is in page 4,000, blah, blah, blah. So a bit of waste, but it was still much, much faster, significantly faster than going through the raw events. At some point, between 2009 and 2010, we outgrew the single file system. It was simply it was too slow to analyze the hours log files. So in our infinite wisdom, we wrote another homegrown library called DDAL. DDAL stood for Distributed Data Analysis Library, and it was heavily influenced by Hadoop, but it didn't do most of the things that Hadoop did. It worked over SSH. There was no central master or anything, but it was a poor man's Hadoop. It would launch jobs remotely. It would run mappers over Harvester, which gave it access to the raw data, and it would do mini aggregations on each node and then send the results back all over SSH to the central one you invoked it on, which would do another final aggregation. This bought us some time, but it also allowed us to start distributing data over multiple servers. The one server was really struggling in terms of storage and compute capacity. So this gave us some breathing room to parallelize where those computations happen and where those files are stored, and balancing the data and all of that. That was mid-2009. All of this was happening, and the output was still the same. We were still persisting key values, output aggregate key values in the PostgreSQL database. And at this point, I believe, there are a few people here from AdGear, I don't know if you remember, but customers started complaining. What we were hoping was an intuitive UI with like sub-second response times became a few seconds. And then slow, we're scrambling to speed things up, but we weren't keeping up with customer demand. And so we said, well, okay, we identified that this key values design is really not efficient. We do way too many queries to produce one report, hundreds, thousands, sometimes millions if you ask for a long-range report. So we said, well, okay, we need to figure out a better data structure that we can pre-compute more so that at report runtime, there is just less work to do to build a report. And by 2010, we replaced Postgres with MongoDB. And this flow stayed the same. We would still build hourly aggregates, but we represented it as a fairly deep tree, and we calculated as many permutations as we can think of to allow the user later to say, I want to report group by X, Y, let's pre-compute it. Y, Z, let's pre-compute it. We had to think ahead and pre-compute all of the permutations so that we can make it fast for the user. And it bought us some time, but we discovered that MongoDB will not run parallel JavaScript. JavaScript is how you query MongoDB at the time. It might have changed, might not, I don't remember. So, moving on to 2011. By 2011, we had gotten rid of MongoDB. We went back to Postgres. However, we did a few, some nuggets of wisdom here. Don't store your reporting metrics in the same database where your application is running. They're completely different concerns. We bought a very big machine to run, dedicated to PostgreSQL for the aggregate metrics. And we built a vanilla, no bells and whistles star schema. Star schema is when you keep your record, you build compound keys, kind of like we were doing in memory, but outputting the compound key with all of the permutations. So we would calculate all of this stuff in memory, send it to Postgres, and the dedicated reporting service, we introduced it as an API layer when we had MongoDB. That stayed the same. So this change, the application, we had to change nothing. The reporting service provided the reporting API to our application, which rendered the user interface. All what we've done is that we've yanked away MongoDB from under it and put in PostgreSDB. We already had reports defined here, so it's just a matter of rewriting JavaScript to SQL. And the SQL in a star schema tends to be very, very simple. It tends to be almost always select field 1, 2, 3, some metric 1 or 2, group by the same fields 1, 2, 3. And again, it bought us some time, but I remember it slowing down. So it's a race. You optimize, and then your users, your company grows, and your users want to do more. You optimize, and it wasn't going very well. Even like the day we introduced this, it was a very small breath, and said, okay, let's try to hit the next milestone before our users complete. In 2012, we replaced some of the legacy stuff that we've been living with. We simplified the log event management to a very simple push mechanism. Each delivery server, when it's done, it tries to push the log to the data warehouse. If it can't, it's going to keep trying. Very self-healing. For the raw event warehousing, we switched to Hadoop. The events land in HDFS as JSON, and then we got rid of CROD because Hadoop didn't offer us the POSIX semantics needed by SQLite anymore. We switched to converting to Avro files. We rewrote most of the aggregation jobs as Hadoop, and we did everything as Hadoop textbook. We wrote the Java code, we wrote MapReduce. We said, well, okay, it's a little bit difficult. I don't want a developer to spend 2-3 days to give me the sum of X. So we played a little bit with Pig. We introduced Hive into the mix. The output from that still went into the same Postgres database for the aggregates, and the reporting service on top of that stays the same. And in 2012, we replaced PostgreSQL with Vertica. This was I'm almost going to cry. This was the final time where we've done a big change that shocked our system, and all our graphs started looking healthy in terms of what the average response time for rendering a report to the user's front end is, to how our systems are doing, and all of the system metrics look good. User report timing, happiness went up. We replaced the Postgres with Vertica, and again, luckily, because we had this abstraction layer for the reporting service, from under it we yanked Postgres, we put in Vertica, and it was not a very big change. It was a tiny bit of SQL, flavor adjustments, but most of this stayed the same. Users just got faster reports. And fast forward to now. We're playing with Kafka, and you'll notice HP Vertica was repeated here. This is because we realized that why are we writing so much logic in Hadoop over the raw events when I have a very fast database that I can bring the raw events to, do my aggregations in solid SQL that I know very well. The data is going to end up there anyways, so I'm reading from the database to do computation to write back to the same database. So this is what our flow looks like right now. The data still comes into Hadoop, but we do very little analysis in Hadoop. Temporarily, for the previous hour, we bring all of the millions or billions of raw events into Vertica, into a temporary table. We have a bunch of ETL SQL that aggregates, does what we want, and back into Vertica, and then we discard that temporary table. We still have all of the data in Hadoop if we need to replay this job or whatever, but hour to hour, Vertica is now doing almost all of the work.
Is it the same instance?
Same instance as, yeah. There's one Vertica instance. That's the data the raw events go into, and it is where the fact table and the dimension tables live. And so here I am talking about HP Vertica. I'm going to give you a little bit of information about it. I'm not paid by HP. Like Jonathan said, I'm just a happy client, and we've struggled to find the secret sauce. And I've talked to other customers of Vertica before it was acquired with HP and after it was acquired HP. And this word secret sauce comes up a lot. It is what enables us to build a reporting interface where there are 2 or 3 widgets and a table and pagination, and all of that renders in under 5 seconds for all of our users. Those widgets are each doing a separate query, and Vertica is what makes this possible for us. So from a developer/operations person's perspective, what is HP Vertica? It's a columnar database. By columnar, I'm talking about how it does things in the back end. It stores things as column, and this is one of the main things that makes it a very fast BI, business intelligence database. It offers a very familiar paradigm for the way most people think about these types of databases. You've got a DB, you've got schemas and tables in them. A table kind of looks like an Excel sheet. You've got rows and columns. When you insert, you're inserting rows. You don't have to concern yourself too much with this notion of columnar. You just know it's a buzzword that makes your database fast. It is distributed and it is horizontally scalable. You run Vertica, you install the software on several servers, and they all start talking to each other. They join a cluster, and there is no one server does a role that is more privileged than other servers. It is equally distributed, and it is very easy if you start hitting bottlenecks, CPU, memory disk, whatever. You toss more hardware at it, but you toss sideways hardware. You're not upgrading your one machine to a bigger, faster machine. It's very easily accessible from the command line interface and from many programming languages. If you've played with Postgres before, if you're familiar with Postgres, because of the history of Vertica, it is actually wire compatible with PostgreSQL. You can connect to it with any Postgres driver. The wire protocol works exactly the same. Some of our systems some of our older systems are actually using the PG library to connect and talk to Vertica. The command line is called VSQL. It sounds a little bit like PSQL. Once you connect, it almost feels like you're in PSQL. / commands, all of that stuff kind of works the same. It is extremely fast. It is a solid SQL database. So unlike Hive, for example, which gives you HQL, but it's not like someone who really wrangles SQL day to day, they find all of the cracks right away. HQL is just not going to give you all of the stuff that you're hoping to write clearly in one statement. So the SQL used in Vertica is very, very solid. Joins work exactly like you would expect joins to work. Optimizations as you would expect them to work. All of that stuff. To operate, it's stable, it's predictable, it's very easy to administer. It's well documented. It is enterprise ready. We use it. We've been using it in production for a long time. It's also used by some very big companies. I know, for example, that Facebook is using it at a crazy ingestion rate. Like they make us look like tiny, tiny, tiny potatoes. So it has quite a lot of production success stories behind it. From my perspective, it is extremely fast, and I can write SQL to do what I want. That's good enough for me. You know, through what we've suffered to reach that point, this is very, very important for us to be able to not worry too much about how the BI database is going to behave, and actually go back to concentrating on building features that are useful to our users. From a product perspective, like I said, it's extremely fast. Now, if you're not familiar with fact tables, this is what one fact table looks like. The job that goes over the raw events aggregates this stuff and appends downwards in an append-only fashion into a fact table. We have a few of these fact tables, and we kind of cluster the fact tables by family. So this is fact table 1. We have fact table 2 that concerns itself with a different set of dimensions, so there's no point making one really wide table. It looks like this, dimensions and metrics. And the whole point of a fact table is to take a row like this. We have summarized 3,551 of the raw events. That is the magic of creating a fact table. You summarize the data, and we end up with something that looks like this. We build a bunch of fact tables. Dimension tables are copies of the data from our main database. A dimension table allows us to join on the fact table to get more info. Our fact tables have IDs in them. What is the creative ID? The campaign ID. All of those are IDs. The data about those IDs are in here. And so when we want to produce a report, in one or two lines, you have the report that you want. So without further ado, 32 minutes in, I'm going to do something a little bit crazy. I'm going to connect to my production cluster because I want to tell you a story. And there's a person here who's laughing, and I want you all to experience this moment. This is Paul, and he used to work with me. And it was Paul's responsibility to take the data from the Postgres database and load it into our test Vertica database. I'm not going to call it a cluster. It was just one machine that we were testing with. And Paul loaded the data, and he said, okay, I've loaded the data, let's run some SQL. So we were gathered around him. And I looked at a report in production of a user who just got a timeout. Timeout means they waited 60 seconds for a report. So I don't know how long that query used to take on Postgres, but it's over 60 seconds. We took the same SQL and said, okay, Paul, run this SQL. And he pastes it in his terminal connected to Vertica, the one Vertica node, and he hits enter. And a number came back. We're like, what just happened? Like, what is this number? And Paul's like, this is the result of your query. Like, there's no way. This query took over 60 seconds. I mean, I know Vertica is fast, but something wrong. There's something wrong. The number is not correct, or we did not load the data in properly, or there was some transformation that we messed up. But sure enough, we took a query, and with very little work, other than upgrading to I call it an upgrade, changing to Vertica, we went from 60 plus seconds to around 35 milliseconds for the same query. So I'm going to try to do this. All right. So this is a Unix terminal connected to VSQL to one of my databases. And let's start with something very, very simple. This is going to give us an idea of the size, which is the number of rows, this is the number of rows in that particular fact table. Now, let me just redo it with timing on. We just counted in that fact table in about 1.5 seconds to get back about 6 billion rows. So this actually is what would be in a classical database called a full table scan. There is no cache for this count. It actually went through it. Now, the reason it did it so fast is, like I said, it's a columnar database. And so it is able to find the column with the lowest cardinality and just quickly go through its metadata and say, well, okay, you've got this many rows. Now, let's look at something actually useful. This here is the query to look at the publisher with the largest volume this month. And I'm going to keep timing enabled just to give you guys a sense of the response times. So in under 1 second, we scanned through the data for this month for this particular publisher ID, and they have this many impressions. Now, because of the way a fact table is designed, I'm actually not sure how many rows it had to go through, because they tend to explode based on the cardinality of the unique permutations for all of your dimensions. But as you can see, when your database is responding this fast, it opens up the possibility for you to do more with your database. Things like caching systems that hide the slowness of a database from your application, well, you don't need to worry about it anymore. You don't need to worry about cache invalidation. You don't need to worry about a lot of these problems. When the database simply is this fast, you don't have to do that much work. Now, I'll admit, a little bit cheated. There is, what's called projections. So the last month is a little bit optimized. So let's stress it a little bit. This is the largest volume publisher all time. So we're not going to add a where clause for the timestamp. So it will be a little bit slower. This all time for this publisher took 5 seconds. Most of the time when a user is browsing your reports, they're not browsing all time. They're looking at today, yesterday, this week, last month, stuff like that. And just to my last query, here I'm going to do a query that's looking for last month for a given publisher. And I want to look at their top performing campaigns, which is the second dimension in the fact table. and I want to look at names, which means I'm going to have to join on the dimension of the campaigns table by ID. And it looks like this when it happens. Now I apologize for the regex replace up there. I don't actually want to show you all of the campaign names for this publisher. But this shows you that the first fetch is 529 milliseconds. And the reason this looks slow is because I paused a little bit in my pager until I went to the next page to show you the result. The time that's important is the data is ready after half a second. So we've got joins, we've got SQL, and we've got an extremely fast database, and we use that to build very innovative reports that we didn't even consider while on the outset thinking too much about which permutations do I need to pre-compute. When you have almost everything in your analytics database, then it really opens up the possibility for you to start thinking creatively about reports. Not only for our customers where we've built reports that are, they're happy with, but for us to explore the data in ways when you have a question, it is no longer expensive. You don't have to send it to a developer to build Java code for you. And if you know just a little bit of basic SQL, you can query it directly. You can connect visualization tools to it because it's a very standard looking database. So you can browse your data in Tableau. Analysts can start playing around. And
storage size of
so the storage, I'm actually not sure of our total storage size. This is a cluster. Data is actually distributed. So if we lose 1 or 2 nodes, we'll be okay. Yeah, probably. In total unique data, we're probably looking at 6-7 terabytes of our full data sets aggregated. Yeah. Now, so there's some good news. When HP acquired Vertica, they wanted to open it up to more people, as opposed to it being like a big stuffy enterprise product. You can actually go to that URL and download it and install it on a virtual machine, on a real machine, and the community edition is free. Now, I don't know of all of the legalities. I'm not going to recommend you run this in production, but you definitely can get your toes wet and play with it. And I really recommend, if you're struggling with the query performance of a database, just dump your data with a copy statement, load it in here, and see what performance you get. In terms of the community edition, this is what I know, and I just copied this from the website. You can load up to 1 terabyte into 3 physical nodes, and there is no time limit. And for more info, you can go to vertica.com. Now on this side, there's AdGear. We're a happy customer of Vertica. And if you have any questions, you can contact me. If you're a publisher or an agency or an advertiser looking for advertising solutions, we'll be happy to meet with you. And again, we're also hiring. So we have several open positions on our company website. If you'd like to work with a great team, please do get in touch. Any questions? The question is, why didn't we choose Vertica or a BI solution from day number 1? The answer is really not that great. We didn't know about them. We didn't know what to look for. We didn't know. We didn't have DBAs on our team. We were mostly developers, so we didn't know what to start looking for. And then by the time we started we started getting a picture of what it is that we want. It has a name. It's called the BI database. There are quite a few out there. At the time, the ones that were approachable weren't really approachable in terms of how much is this going to cost. It was very, very difficult. Yeah, and then I also believe that at the time, during our early struggles, Vertica was still a project. I think it was called like a C-store. It wasn't really commercialized at the point. So the other alternatives were really, really big names that we knew we couldn't even, they wouldn't return the phone call back if we say, we were a tiny company in Montreal and we want to hear about what you have. So after Postgres, we knew that it was time for us to find the right solution where we don't have to every year or two redo it from scratch. And after some research, we said, well, okay, this is definitely what we want. We want a distributed database. So we started laying out the characteristics that are no longer negotiable for us. We want something that's horizontally scalable. Ideally, it offers SQL. So we're not, learning some new paradigm from scratch. It has to be columnar because that's how we knew we were going to solve the speed issue. So we made a long list and it kept getting shorter and shorter. At the end, I remember there were only 3. Vertica, Greenplum, yeah, and I actually downloaded it and I started playing with it, but I think Vertica was just very impressive. And the third one, I believe, was maybe Natiza. I don't remember if that's the right one or not. But it boiled down to 3, and Vertica is what we managed to make work right away, and the results were extremely impressive. At that point, we rechecked. Yes, it's going to do this, and this. It was just a question of how much at that point to go to production with it. And going to prod was really quite simple because there's nothing really new to learn. You're still thinking of tables, and for the most part, our data was a copy, not a transformation. Yeah, so the question is, since it's so fast, why do we have multiple fact tables instead of creating one fact table that's extremely wide? And the reason is we had actually started with something like that, but it's fast, but nothing is free. And what we ended up realizing is quite often our reports tend to cluster themselves into families. There's first party stuff that is left anchored by who the publisher is. And then there's third party stuff that is on the left. It should be anchored by who the agency is or who the advertiser is. And it is actually quite rare, aside from our internal reports where we're doing like a total sum at the end of the month for our billing purposes, for example, to be using both types of data at the same time. So it just made sense, and we got another speed increase from clustering into fact table number 1 that's going to deal with publisher fields, and fact table number 2 that's going to deal with agency fields. Fact table number 3 is going to deal with the RTB buy platform. Fact table number 4 is for the RTB seller platform. For the most part, it works this way. And we didn't really sacrifice that much because when we want to run aggregate queries, there is no magic to it. You query table 1, union table 2, union table 3, table 4, and then on the outer query, you get the, you sum up what you want.
Yeah.
The migration was, most of the time we spent on migration was testing. A lot of our queries ran verbatim. So the queries themselves, they ran okay. So we just spent, the data copy was, it didn't take that long. And then we spent a few weeks just testing everything, making sure that there were no regressions in data accuracy.
Can you do a PG dump and reload it back, or?
So a vanilla PG dump, no, but I think we ended up doing copy statements. So if you have tab delimited data, copy out. And I think at some point we even skipped the file system, so it was copy through a pipe through a copy in. Yeah. So if you're using the rich, if you're using the rich data types in Postgres, you're going to have to flatten it.
So if we partition the data using inheritance,
Mm-hmm.
we have to.
I don't think it has table inheritance, but most of the time you're doing inheritance as a speed optimization. So you don't end up fighting that for speed that much. Now what you do gain is a fast database, and there are some really nice features in Vertica that we haven't played with that much. A couple of years ago they introduced dark data. Dark data is unstructured data that you can bring in, JSON for example, that you can immediately start querying. It's not going to be as fast as a properly defined columnar table, but it makes data exploration really, really nice. Once you've mastered the SQL, the full SQL syntax that it gives you. And I'm talking about a lot of really, really nice functions, windowing functions, analytical functions. I know companies are using it for semi-real-time threat detection, fraud detection, all of that stuff. It goes through Vertica. We have been running for a few years on 6 Vertica nodes. They are medium-end Dell servers. The main thing that we've done is we've just replaced the spinning disk with SSDs on day 1. And that's it. I don't know, Francois, if you want to say what the average load is on the cluster, for example. Pretty low. Yeah, so at this point, you're going to get a little bit into the details. That's why, if you really care about this stuff, then you have to learn about what columnar is implemented as. You define your table the same way you define any other table. Here is my, it's called X, its data type is Y, nulls default, allowed yes or no, default blah blah blah. And you define all of this stuff. Now, what happens is when you create when you define a table in Vertica, unlike Postgres, for example, the data is not stored in a table. It's stored in what's called a projection, and you can almost think of a projection as an index. Now, by default, you're going to get a projection that has all of your fields. You don't have to worry about this stuff. You only start learning about this stuff when you want to start optimizing, because the order of fields in a projection is a little bit like the order of fields in an index. If you want to start getting faster queries for fields that were not on the left side of your projection, you can create more projections. And creating more projections is going to take up more disk space. If you have a contract with HP, it does not contribute to your licensing cost. So the licensing cost is based on the data that you're putting in, not on how many different projections you're going to create. So we haven't actually tried taking the data straight to Vertica. I like the idea of the data landing in Hadoop, because that's when we can start doing sanity checks. For example, if we know that there are 100 live delivery servers, I don't want to start analyzing this data before the 100 log files are sitting in the directory. So we still have a bit of legacy, but it works well, business logic, where the data must appear in Hadoop and we must do some basic sanity checks before we start analyzing it. Now, recently we've said, well, okay, once it lands in Hadoop, that's the landing area, let's copy it into Vertica, and this is an operation that we can repeat. For example, if we have a bug in the aggregate code, we can just do it again. But more and more we're doing analysis in Vertica. What we're still using Hadoop for is a particular type of metric that needs to be aggregated, where we need to cluster events by individual users and go back in their history to do stuff like conversions. So a user converted, hit a conversion pixel, and let's try to go back and look for advertiser activity, impressions or clicks that we have exposed the user to try to say, and I hate the word, but to try to say, this user bought this shoe because they clicked on this ad, with various degrees of certainty for this, because we try to do that. And when we offer our clients, is actually a fairly lenient look-back window for how long this data we can look back to. And it did not, at the last time we looked at it, it didn't make sense for us to persist that much raw data in Vertica for this feature. So that feature is still a Hadoop job, where we look back through many days worth of data, and we've optimized both on the software and on the data representation to allow us to do this as efficiently as possible. So that's one of the main jobs still left in Hadoop. The output is still the same. The output, the aggregate of the conversion analysis, ends up going into Vertica, and then from there we just do reports.
How long does it take from the time the event occurs to the time it's reportable?
So how long does it take from the time the event occurs till it's reportable? We have actually, I've concentrated on our batch system. We have a real-time system, and that it really depends on like internet latency type of thing. It can be 70, 80 milliseconds from east to west, or if we have to get it from Asia or Europe, it's a little bit longer. That affects our real-time interface. However, the real-time interface, to keep things simple, is tolerably lossy. For data that is closed, that we're going to report based on, they are hourly batches. And our job, as of the last optimization, our aggregation jobs take about 10 minutes, which means at 9:10, you should see the activity as of 8:59, 59. So the question was, how well is the support in terms of replication and failover? Because there are no nodes with more privileged roles than others, it is fairly easy to treat all nodes the same. There's no master, there's nothing like that. No. You can connect to any node, you can issue a query, it will distribute your query's workload in terms of CPU, disk access, all of this stuff on all of the nodes that have the data. So it works fairly well. I think 1 or 2 times we've had trouble with one machine where we've had to restart it and whatnot. It comes back, it resynchronizes with the cluster. Between 5 and 10 minutes, it's back in full service. We have not had a cluster-wide outage. Yeah, I mean, it was early days, but we did have like a software bug. I'll be honest, there was a software bug, and we were doing some pretty inventive SQL to try to do some clever things, and we triggered a bug that hit a safety violation in the system. So it wasn't so much a crash as much as the system saying, I'm not going to keep operating because I don't want to give you wrong numbers. Starting it back up was simple. You just go to the admin interface and say, start the cluster back up. That was a few years ago, and other than that, it's been fairly stable. There are no operational surprises that I can recall happening recently.
So you only have one copy of the data?
So for disaster recovery, we have the data somewhere else. If we have to rebuild, we can restore, and it comes with pretty decent backup systems, a backup script built in. You can use to do semi-incremental backups, so I can restore the state of the cluster to any point in time in the last 7 days. That's my disaster recovery constraint. Yeah, so the question is, since we're running the aggregation in Vertica, do we see a query slowdown while this is happening? Yes, there is a query slowdown, at least there was initially. Now we investigated further, and Vertica actually has resource allocation. So you can classify your queries as to they're allowed this much resource of the cluster. We simply minimize the parallelism of these queries because we have to populate multiple fact tables. So we said, well, okay, let's not do everything at once. We can tolerate for them to happen semi-sequentially, and let's put them in a lower priority so they don't interfere with the production read workload. And I think we're pretty successful in removing that first beginning of the hour slowdown that we observed. Okay, so the question, can I talk about the bad side and whether it was an issue for HP to acquire Vertica? The bad side, are you talking technically or? Okay, technically transactions don't work exactly as you'd expect. Yeah. You do pay a cost for the speed that you're going to get at read time. So I would recommend Vertica if you're primarily doing reads. If you're, I don't have experience using it for something other than that. When you begin a transaction and you roll it back, some things are a little bit funny. You might, for example, put a uniqueness constraint on a table across multiple fields. It will tell you that you violated it, but not at the time you're expecting. Now, regarding the HP acquisition, no, there's been almost no difference from my perspective in terms of the product. Well, of course, it's continued to mature, so these issues that we ran into, they've disappeared. The documentation, gained a much better polish, and it's more thorough. And the support is equally good before and after. So the question is, what are we using for the presentation layer? On top of Vertica, there is a reporting service. This is an abstraction that we've written that provides reports as an API to the rest of our products. This is just JSON, ugly, does the job, but there's no presentation to it. The presentation layer, we've invested heavily in building it ourselves. So we have quite a fairly rich JavaScript UI that can render this data in multiple variations and react to the user asking for X, Y, and Z in the most efficient manner possible to redraw as little as possible. So it really feels extremely fluid when you're using the UI to get data for the boring stuff like the monthly report, as well as to discover. Where did my ad serve? What are the most popular sites that I've spent on? What's good value? What's bad value? The discoverability is all custom built. Yeah. So the question is, what's the replication factor? I believe it's currently set to 2, which means we can tolerate 2 nodes going down. If that happens, we're not going to suffer from data loss. We're going to suffer from the clusters violating the safety constraint and shutting itself down. And then worst case scenario, if we physically lose more, it's time for disaster recovery and a little bit of sweat and tears. So the question is the API for the reporting service connected to Vertica and Hadoop at the same time? Initially, we had planned for it this way. That way you can ask for a report and it will find the best data source to give you the data for that report. Go to Vertica. If it's not something Vertica can satisfy, magically launch a Hadoop job for you and get you your data and normalize it and present it. We never got around to this step number 2. So the reporting layer is purely an API on top of Vertica right now. And that's because I didn't want the application, the various applications that we're building and the various widgets within them to have to worry about what the aggregate data store is, if it's Vertica, what the semantics are, how far away am I from them. So they just talk with a very well-defined API that we're actually thinking about for our customers, potentially giving them access directly to run reports programmatically as opposed to having to go through the application. So we wanted an abstraction layer that's clean and it's a good service boundary between the data coming out from whatever form it's in and then given to the application or to the end user. We played with the idea of landing some real-time data in Vertica, and it's actually quite easily doable. To provide a window. It's unsafe. It's unsafe as in you cannot build based on it, because most of the time when you have a Lambda architecture like that, you end up discarding your real-time window after a while. But we honestly never got around to implementing it. From what we're seeing, most of the time the users are exploring, and if they want to see how something is performing, it's because they want to observe the result of a change that they've put into the system. Did my ad go live yet? This and that. They can actually use the real-time interface to watch it. But to look at what's classically called a report and have the numbers change every few seconds, we didn't find it was necessary to build that. So what's the pricing for this? I can only speak about what my experience is, and we've been early customers of Vertica. I'm going to have to ask Jonathan to come up to take the non-technical questions. So the question is, do we have to adjust our hiring process? And if we did, how did it go here in Montreal?
Not the process, but let's say the target.
Yeah. So we have not gone out of our way to hire someone with Vertica experience. We haven't tried. The way the data team grew is just really good people who love to play with whatever the best technology for the job is. And this is a small subset of the full stack of AdGear. We've got back-end servers and front-end servers, different technologies. We really use the best tool for the job. So when people have started and they get exposed to the BI layer and okay, Vertica, okay, never heard of it. We start reading documentation, and it's intuitive and it makes sense. So it hasn't been hard to ramp people up to operate it efficiently. And honestly, in terms of all of my systems, I don't worry about this one too much. It's a good piece of software. It stays up, does its job. It's quite predictable. So it hasn't been challenging to keep it up or to maintain it. But we haven't had an urgent need, for example, to hire like a DBA specialist to solve a Vertica problem and start tailoring a job hunt for that. So the question is, do we store IP address in the fact table? No, we don't. In the dimensions, no, we don't either. Okay, so the whole point of taking raw events and putting them in the fact table is to summarize as much as possible. So we look at the fields that we can imagine wanting to query based on. And a lot of the stuff that's what's called high cardinality, which means there are a lot of distinct values. IP addresses, user IDs, stuff like that. It is not part of our BI schema because it would basically give us a very bad summary ratio. Summary ratio is how many raw events got translated into how many rows entering your fact table. When you keep really high cardinality data, it makes this a moot exercise. We might as well bring in all of the raw data and put it in Vertica. And for us, we're still, the size of the company means we can't actually afford to do that. So we summarize as much as possible. Having said that, Vertica actually has some pretty interesting user-defined functions, and we were able to cheat and take some of this high cardinality data, use some pretty nice data structures, some are well known, some are less well known, and store some information along with custom functions in Vertica that allows us to get some of these numbers. like how many unique IP addresses were, seeing this ad on site X and Y. We can still do these queries in sub-second, but we've had to cheat a little bit in terms of the accuracy of those particular metrics.